Okay, welcome back. In this video, we continue the concept of sequences. Okay, we'll give concrete examples, and after that, we're gonna start a general discussion of sequences using the concept of the limit. Okay, let's assume that a person walks every day 1 kilometer or 1 mile. So let's say day one he walks 1 kilometer or 1 mile, day two 1 mile, day three 1 mile, and etc. Assume that this person lives forever. Okay, so on day n he walks 1 mile or 1 kilometer. Okay, so in this case we defined a function from the set n into n such for every n we have 1, or just the f of 1 is 1 for any n. Okay, so this is a function, but since the domain of definition is n or part of n, so we call it a sequence. Okay, because we are interested in these quantities 1, 2, 3, 4, 5, etc. So in this case we use this notation. We say u21 is 1, u2 is 1, u3 is 1, un is 1. Okay, every day he walks 1 mile. Okay, so the u1 is just f of 1. Okay, u sub n is just f of n. So we use this notation. So use any letter and we use the sub-index, okay, subscript here to denote the variable n. Okay, in this case u sub n is 1. Okay, and in this case we defined a sequence that tells us about how many kilometers or miles this person runs every day. Okay, so another key idea is that we can graph it. Okay, so we use the set here as the set of integer, the positive integers 1, 2, 3, okay, 4, 5. Okay, and here we have day 1 is 1 mile, day 2 just 1 mile, day 3 1 mile, day 4 1 mile, etc. Okay, and we see as n keeps getting bigger and bigger, we always have 1. Okay, in this case we write the limit of un is 1 as n goes to infinity. Okay, well, in fact here we have defined what we call a constant sequence, okay, or a constant function, because u sub n, which is f of n, is 1 for all n. Okay, for all n in n. So because we are introducing this concept of limit because it's part of the sequence. Okay, it's very beautiful. We are interested in what happens in the long run for sequences. Okay, so this is a notation that we use. The limit of un as n goes to infinity is 1. Here it's clear. It's clear. Sometimes it's not clear at all, and we need to now learn and understand techniques that would definitely help us finding limits. Let's say we define a sequence by this: u sub n, it's e to the minus n over n squared plus 3. Okay, so what's the limit of u n as n goes to infinity? What's this limit? We can tell. We can tell. There are some tricks that we can use, but we can tell. But another one is like, what's the limit of n plus 1 over square root of n plus n? Okay, so if we define this sequence in this way, what's the limit? So anything that we can use, we can find a limit for it, because we are interested in what's happening in the when n gets bigger. Okay. So another thing is that a sequence is defined from the set n or any subset of n into n. We use the sub-index notation to denote the general form of the sequence. Okay, so u sub n is just f of n, where f is the function that we are studying. We'll give more concrete examples, and we will in one last video about this concept of the sequences. Thank you.